Did you know that up to 70% of global consumers self-identify as having sensitive skin, yet are not fully satisfied with current solutions? The problem is not the products, but the question they have been answering. Modern life has altered the skin's immune behavior. Today, humans spend 80 to 90% of their time indoors, exposed to an invisible cocktail of aggressors. Indoor pollution is the unaddressed driver of the sensitive skin epidemic. Chronic pollutant exposure conditions the skin's immune system to default to reaction. The skin fails to distinguish a harmless urban irritant from a genuine threat and loses its tolerance. At the heart of this immune miscalibration are Langerhans cells, the skin's key immune decision-makers, largely overlooked in cosmetics. Chronic pollutant exposure locks them in a state of permanent activation, triggering persistent redness, sensitivity, and reactivity. This exposure triggers Langerhans cell activation, barrier disruption, and an inflammatory cytokine microenvironment, locking the skin in a cycle of hyperreactivity. The solution is not to silence this signal, it is to retrain the system. Vitrus unveils Toleroxyl, the world's first cosmetic tolerogen, a new cosmetic category designed to re-educate urban skin beyond traditional soothing approaches. This biotech active ingredient trains the skin's immune system to generate tolerance, not suppress responses, but educate immune cells to stop overreacting to harmless stimuli. To deliver this tolerogenic signal with molecular precision, Vitrus turned to nature as a biofactory to produce a full-length recombinant human protein. The active molecule is GM-CSF, a protein naturally produced by the skin that governs differentiation, survival, and tolerogenic programming of Langerhans cells. Urban, chronically stressed, and aged skin progressively loses this endogenous signal, shifting Langerhans cells from tolerance towards chronic inflammation. Toleroxyl binds to GM-CSF receptors on Langerhans cells, triggering a key pathway to keep these cells in a calm, tolerance-supporting state. Calmed Langerhans cells secrete TGF-beta, which helps reduce inflammatory signals, promoting a healthy, non-inflamed skin environment and restoring the skin's natural immune balance. By reprogramming LCs into a tolerogenic state, Toleroxyl helps reduce inflammation at its source and restore the skin's natural immune balance. To validate this mechanism, Toleroxyl was tested on reconstructed human epidermis containing Langerhans cells, challenged with an indoor pollution cocktail. Gene expression was analyzed for key inflammatory, tolerogenic, and barrier markers against a dexamethasone-treated positive control. Indoor pollution triggered a plus 136% surge in CCR7 expression, driving Langerhans cell migration and activating an immunogenic cascade. Toleroxyl achieved full normalization at the tested doses, while restoring co-stimulatory maturation markers CD80 and CD86 back to physiological levels. Toleroxyl restored tolerogenic transcription factors disrupted by pollutant exposure. The anti-inflammatory cytokine TGF-beta suppressed by indoor pollution was boosted by up to plus 28%, confirming a genuine tolerogenic reset. Toleroxyl rebuilt the epidermal barrier, restoring filaggrin and loricrin, reversing stress-induced structural degradation. Tight junction proteins were also significantly upregulated, providing a multi-layer barrier restoration effect. Toleroxyl was evaluated in volunteers with dermatologically diagnosed hyperreactive skin who spent a minimum of 16 hours per day indoors. In the first assay, Toleroxyl reduced the skin redness by up to 30% after just 14 days, reaching an up to 41% reduction at 28 days. Over 90% of volunteers showed clinical improvement in erythema at day 28. All functional signs of hyperreactive skin showed significant improvement, with 100% of volunteers reporting benefits at day 28. Skin cytokine profiling confirmed the immunomodulatory mechanism in vivo, reducing inflammatory cytokines versus placebo. In a second clinical assay, Toleroxyl was also tested on volunteers with hyperreactive skin and chronic indoor pollution exposure. The active demonstrated a statistically significant efficacy versus placebo, decreasing skin redness down to minus 65%. For the first time in cosmetics, an active ingredient targets the root cause of hyperreactive skin, not by silencing the response, but by re-educating the skin when to stand down. A biotechnology solution inspired by nature and backed by science for demanding cosmetic consumers. Toleroxyl, re-educating urban skin. Feel free to contact Vitrus technical team for further information.